Yes, we can after.
And this must be the line you all must have heard probably 20 times by now since yesterday. But we should all used to it now. So anyway, moving forward, thank you everyone for joining the session, and more people are joining, coming back from the um, hop-in social area. So I think you're having a good time talking to other people as well. So finally, we are getting some social aspect of the APNIC meetings as well. Unfortunately, we are not in Dhaka at the moment. So hopefully, one day, very soon, we will be able to visit in person. So welcome to the Routing Security SIG. This is the formally the second meeting, SIG meeting after the approval of charter and everything. So this is the formal event we are moving ahead with. Let me introduce you to my acting co-chairs, Dr. D. Ma and Rupesh Shrestha. Dr. D. Ma is from ZDNS and Rupesh Shrestha is from Nepal Internet Exchange Point. So I see Dima is there, but Rupesh is not there yet. So they are part of the team, and we've been working for quite some time to make sure that we have a agenda. The agenda is pretty good, and it's going to be a tough battle to make sure that everything is sandwiched between the time allocated. But don't worry, we have a whole evening, so because this is the last session of the day. So if there is a time spillover, we will try not to, but I hope you can all stay back to have this discussion. Right. So let me first call upon our presenter. We have um, uh, let me have a look. We have Yunan Go from Huawei, and she'll be talking about the BGP routing security and the region-based trust alliance validation. So over to you, Yunan.
Hello. Hi, can you all hear me clearly?
Yes, we can. Go ahead, please.
Shall I share the screen or you will share the screen?
You can share the screen.
Okay. So okay. So a little bit just self-introduction. So my name is Yunan from Huawei, and this is actually my first time attending APNIC, and it's very nice to meet you all online. So today I'm going to discuss with you about a solution that we have recently proposed, which is of course regarding routine security, and it is named as region-based trust alliance, abbreviated as RITA. Okay, so I would say that this solution is more than just like a simple protocol extension or operational enhancement. It is more like a new framework that we can use to enhance the hijack detection. Okay, so let's get started. So I'm going to start with a hijack use case. Okay, so now suppose we have a host who wants to visit the destination server, and so normally this destination server would advertise the network 100.1.1/23 all the way to the host. Okay, just as a green path shows. And possibly at S4, the route is also advertised to S100. And then S100 will continue to propagate the route, and which is also received at S1. So if S100 does not make any specific changes to the route, then possibly at S1, it will select the route received from S4 over the route received from S100, because this route has a shorter AS path. But now suppose AS100 becomes an hijacker, it advertises a more specific route with the mask 24, okay? So now S1 would select the route from S100 over the one with the mask 23, okay? And then as a result, the traffic flow is hijacked by the S100. And of course, there have been some hijack detection solutions, such as the RPKI route origin validation, and also another ongoing work, which is called ASPA. So the idea of ASPA is that the autonomous systems will assign their provider objects at RPKI. So all the routers can download the objects to detect if there's any violation in the AS path, okay? But in this case, we see using either route origin validation or the ASPA method, there's no way to detect this hijack because first of all, the origin of the AS path does not change, okay? And secondly, S100 did not change anything about the AS path, so SPA also won't detect any violation. And even though, let's assume S4 does not advertise the route to S100, AS100 can just, directly forge a more specific route. And even in this way, the ASPA isn't able to detect this hijack because let's have a small summary. So for hijacks that does not violate the ROA or ASPA objects, it is typically hard to detect such cases. And so today, I'm going to propose a solution that could possibly solve this case, okay? So before I introduce the steps or the principles of our method, I would like to introduce two concepts. The first one is a region concept. So the region are a group of ASs who wants to protect the routes that originated from this region against hijacks from outside the region, okay? And we suggest the region to be ISP-wise. For example, several subnets of the same ISP, because they are under the same management domain, they could comprise a region. And under this region, we suppose that the routers within the same region, they are trustworthy, meaning that they don't hijack each other. They will protect them, the members within this region from hijacks outside this region, okay? And then the second concept is the trust aliens, okay? And the trust aliens are a group of regions, okay? And you can imagine, that's for example, the regions or ISPs from the same country, they could comprise a trust aliens. So the purpose of the trust alien is to for the members to protect each other from, again, the hijacks from attackers or devices outside the trust aliens. And there's one requirement for the trust aliens members, which is that each region must be connected directly to each other through BGP, okay? So let's use a small summary to highlight the purpose or the benefit of our proposal, okay? So what we want to do is that we want to protect the routes that are originated from our own region or from our own trust aliens from being hijacked by those members outside the region or the trust aliens, okay? And I want to use the example to show you how actually the region and the trust aliens are divided, okay? So suppose in the same example, several subnets of the ISP1, they can form region 1. Okay, so these ASs within this region, they can trust each other. Okay, so they will protect the routes originated from this region against hijacks from outside. Okay, and then for ISP2, it can also form a second region. And then several regions will form a trust alien. For example, these ISPs from the same country. Okay, and there could be also multiple trust aliases. Okay, and here are two specific use cases that we can use this solution to protect against. The first use case is in showing here. So in this case, we have the routes which are originated from the trust aliens, but the protector is in a different region within the with the routes. Okay, and the second case is that we want to protect the routes that are originated from the same region as the protector. Okay, and later we'll look at the details how it is achieved. And a little bit pre-requirement of our solution. So we need the RPKI root origin validation. Okay, so the root origin validation not only provides you with the origin AS information. So our method only proceeds when the ROV validation shows valid or unknown. Okay, and this information also provides the mapping of the routes to the origin region and as well as the origin trust alien. So which means I want to know whether the routes is under my protection or not. For example, if the routes are originated from my own region or trust alien, I will protect it. Otherwise, I will not. Okay. And then the validation rules are simple. Okay, so for the routes which are originated from the same region of myself, I will check if this route is received from a device, whether inside or outside my region. If it's outside the region, I will simply reject it because I cannot trust devices who is outside my region. Okay, and the second principle is that if this route is originated within the same trust alien, but not within my same region, I will also protect it. And I will need to check the BGP peer who sent this route, whether it's within the trust alien or not. If it's outside the trust alien, I will also reject it. Okay, so the principle is quite simple. So next, let's take detailed look at the step-by-step procedures. Okay, so before everything happens, we need to, have mutual agreements between the ISPs, which means they need to form the regions and the trust aliens. So it could be either by, oral agreement or a contract agreement, and the details are left to be, discussed. And after the agreement are reached between the cooperative ISPs, the next step for the ISPs is that they need to sign their RITA profiles, or say RITA objects to RPKI, which shall include information which including the trust alien number, the region number, as well as the AS number. Okay, and the detailed format of this object will be defined at IETF. Okay, and then after these objects are signed by the ISPs, routers will be able to download this information from the RPKI server. Okay, and this information is used to actually decide the roles of your eBGP peers. We want to know if a peer is within the same region as you or within the same trust alien as you. Okay, And the third step is that it's triggered when the root is actually received at a router. Okay, so first we need to do the root origin validation. And when the results returns valid or unknown, we'll take the further step. Okay, and also this origin AS will be used to indicate whether this root is under my protection or not. It tells you whether it's within your region or it's within your trust aliens, okay? And if this root is under the same region as you, and then you need to check the eBGP peer row to see if it's under the same region as you. If not, you will reject the roots. And if the root is within the same trust alien, but not under the same region as you, then you also check the eBGP peer to see if it's under the same trust alien as you. If not, then you will reject the roots. Okay. So these are the steps. And so next I'm going to use two examples to show you how this solution could actually work in the example I provided previously. Okay. So in here, we can see that ISP1 forms region 1 and ISP2 are region 2, and they comprise a trust alien 1. So these objects are signed by ISP1 and ISP2. So all the SBRs from the ISPs, they will need to download the RETA information from the RP server. So they can know the eBGP peers of their BGP peers. And then now suppose this, so at S1, suppose it receives a root from S100. We can see S100 is now currently a non-trust alien member of S1. So when it receives a root that is originated within this trust alien, it will reject this root. So in this case, the hijack fails, okay? And then in the second scenario, it is, the idea is similar. At S1, it also checks, it finds out that S100 is also outside from its own region, and it will reject the roots. And while on the other hand, the correct root is correctly propagated from S3 to S2, because at S2, it finds out that the root is originated from region 1 and also received from a neighbor in region 1, okay? And so these are the general ideas of our proposal. And here are some next steps that we want to do. So first, we want to take this proposal to ITF, because we can see there are some standardized works to be done. And secondly, we also want to plan a demo. To be honest, we have done a demo by ourselves last year, but now we would like to appreciate more, actual participants from ISPs. So if you're interested or anything, just use the email to find me. And for now, any questions or comments?
Thank you so much, Yunan, for this interesting proposal. Of course, you'll be doing it in ITF, and you'll get more feedback from there. But just a couple of consideration. I mean, Jeff mentioned one thing, that in your scenario, if AS5 created a /23 ROA with a /23 maxLN 23, then in a specific /24 would have become invalid all of a sudden. But anyway, going into another, I'll just pose another question on that one. Is regions are very fuzzy boundaries at the moment, right? For most of the operators. So how do you define a region? Are you going to define the region on the RIR boundaries? I mean, many operators do not even work within the RIR boundaries. They are, it's pretty flat in that moment, in that manner.
Right. I agree with you. I think this is also something that we would like to discuss with more people about how to, define a region and how to form a region.
Okay, and again, personal experience that if you have to negotiate with other ISPs with multiple commercial interests, it's going to be a very, very difficult job moving forward. But anyway, it's an interesting idea. Let's see how it goes in the ITF, and I'll be following the CyberOps working group and see
Yeah,
how it
I
goes.
guess we could like start from small, a small group of ISPs or operators who are interested, and then because we don't have like a fixed size for the trust aliens, right? More people in, and we can protect each other. But less people, we can also protect each other. Yeah.
Yeah. So there's one comment plus question from Jeff is this is an odd way of constraining the AS path. This concept was used in AS set in RPSL decades ago, and it really did not take off then. Why is this any different, I think, as compared to the AS set?
Okay. I think I'll check this question offline, maybe.
Okay, we have another one coming in. I'm just making it live from Baha Al Musawi. How to
Mm-hmm.
avoid the problem of an AS with multiple
Yes.
countries?
Yes. Yeah, that's a good question, actually. Yeah.
Yeah, I mean,
I
a
think
simple
we haven't
example.
actually figured that out yet.
Yeah, it's as I said, boundaries on the internet are very fuzzy. They don't
Mm-hmm.
exist, right? So, um, putting
I
everything
guess
in a
probably
boundary, yes.
I have a very quick reply here because currently in the RITA profile we use the trust alien number, the region number, and the S number. Probably if we can use a new identification other than the S number, for example, S number plus the location ID or something like that to identify extra I mean, an S in different locations.
Okay, so I think we all should follow you up on the CyberOps working group once you post it over there. So that would be interesting.
Yes.
Good. Thank you so
Yes.
much, Yunango, for your
Mhm.
presentation and
Thank you
your
all.
proposal. Now,
Mhm.
if
Nice
you
for
have
sharing.
to everyone, if you have any question or concern or would like to discuss more, you can definitely reach out to Yunan to our email address. Moving on to the next presentation. Since we were talking about CyberOps, we have Dr. Dima who will be discussing what actually happening in the CyberOps. One thing I would like to share is um, few weeks ago, I was talking to somebody and they said, "Oh, have you read the RFC?" And I said, "Yes, I have." But when I started compiling the list of RFCs concerning about RPKI and how to implement it and the operational aspects of the RPKI and the relying party software, it's a very long list. So let's see how CyberOps is dealing with it. And to explain that, we have Dr. Dima. Dr. D, over to you.
Hi, FTAB.
Hey, we can hear you loud and clear. Please go ahead.
Okay. Um, Good afternoon, everyone. I'm Dima from DNS, and also the administrator of Upster, an open source RPK reliant party software project. I have been working on RPK related research and engineering tasks for more than a decade since I was a graduate student. I spent a lot of time working with other experts on RPKI related standards at ITF. And so far, I'm also the author of 3 RFC documents from Side Working Group and Side Ops Working Group, respectively. Today, with my routing security SIG co-chair head off, I'm honored to take this opportunity to share my personal point of view on what's going on with the ITF Side Ops Working Group, which, by the way, is where RPK-based routing security techniques are being standardized and best practice are being shared. Hey. As we all know, the IETF standards defining the RPK have been developed in CIDR, which, by the way, was concluded in September 2018. And RFC documents made by CIDR working group fundamentally provide the RPK trust model of authorization hierarchy, format of sign objects, validation algorithm, threat model, and so on. Almost everything the internet community need to know, need to have got to implement RPKI and its applications. Among others, the most remarkable application of the RPKI are BGP origin validation and BGP path authorization, which is known as brand new protocol called BGP SIG. In short, with efforts made by CIDR working group, RPK is ready to support secure interdomain routing. Well, RPK is ready to support secure interdomain routing, and RPK is right in use of supporting secure interdomain routing. Above all, on the provisioning side of the global RPK, 5 IRs have offered production service as of today, and there is an increasing number of both IPv4 and IPv6 address space being certified by the RPKI. And RPK adoption is really promising if we take a look at its adoption rate in recent years. In addition, more complete support is available from IR to make delegation model of internet number resource certification, which is going to help ISP, ICP, or XP take full responsibility of RPK operations. Well, with ISP being mentioned, RPK-based RV is rolling out with the increasing numbers of ISP worldwide, as illustrated by the statistics by Cloudflare. We can see many tier 1 ISPs and the top ISP are doing route filtering with the RPK data. So accordingly, it's safe for us to say vendors are supporting roles such as Cisco, Huawei, Juniper, and more. RPK is also recommended by maturely agreed norms for routing security initiated by SOC. So I'm therefore reassured that RPK ecosystem has been established substantially. That is all about the background where the IETF side ops is working on. RPK is in operation, and operation is always yet another important thing. As we all know, a set of technical standards could be a mighty guide, but not prerequisite for success of the RPK operation in practice. One can easily find many operation-related working groups at IETF for this reason. So with respect to operations of the RPK and its applications, RPK-based routing validation is in a large scale, for instance, calls for best practices. CIDR Ops was chartered and formed to succeed CIDR working group in terms of RPK standardization. It's chartered to develop guidelines for the operation of CIDR-aware networks and provide operational guidance on how to deploy and operate CIDR techniques in existing and new networks. Moving along to this slide, we can know what is CIDR Ops working group for right away specifically. Years of RPK-based routing security practice calls for retrofits by the IETF. At first, standards without being reviewed by practice cannot deliberate on every details operation. Retrofitting some of technical standards is therefore inevitable. Manifest update, among others, is the most important task for the working group at present. The working group agrees that the manifest RFC allowed RPs too much flexibility in deciding how to respond to less than perfect manifest or publication point standards. A revised version of this RFC removes all ambiguity, requiring that CAs can maintain publication points and manifests in a strict fashion. The CIDR Ops working group is now debating whether it wants to require such strictness or to tolerate some errors that are perceived to be non-critical. To close this argument of mine, I would like to quote from Dr. Stephen Kent, who is one of the RPK designers. It said John Postle's robustness principle is appropriate for promoting interoperability, but it's not a good principle for security. So security requires discipline. Okay, so that's all about the manifest update. I'm really looking for this discussion in the coming future inside the Ops Working Group, like ESPA. By arguing that strict cryptographic validation by BGP SEC will bring expensive computational overhead for BGP routers, some experts propose an alternative approach by using a shared signed database of customer to provider relationships using a new RPK object, Autonomous System Provider Authorization, ESP for short. Now, two documents are about deployments. One is the requirements for RPK relying parties. This document provides a single reference point for requirements for relying party software for using the RPKI. It cites requirements that appear in several RPK documents, making it easier for implementers to become aware of these requirements. Over time, this IFC will be updated to reflect changes to the requirements and the guidelines specific in the RC discussed hearing. As for the RPK-based ROV on export, a BGP speaker may perform RPK origin validation not only on routes received from BGP labels and routes that are redistributed from other routing protocols, but also on routes it sends to BGP labels. For egress policy, it's important that the classification uses the effective origin ES of the processor routes, which may specifically be altered by the commonly available knobs, such as removing private ES, confederation handling, and other modification of the origin ES. Okay, this draft clarifies the ROV implementations must use the effective origin ES to determine the origin validation states when applying egress policy. As I said, a set of technical standards could be a mighty guide, but not a prerequisite for success of the RPK operation in practice. So no wonder there are some issues we have to handle as we are taking use of the RPK in terms of data format, such as row maximums, BGP validation state signaling, timing parameters in RPK-based ROV supply chain, which are being addressed respectively in those drafts below. Although this is not a working group item yet, but this proposal I think is also was my mentioning. It's about distributing validated cache from one server to another. It's RUSH for short. This draft is to define a mechanism called RPK validated cache update in SLUM over HTTPS for the use of SLUM in updating RPK cache data over HTTP. If you are already familiar with SLUM, you will know, you understand why we are resort to SLUM format to convey the update information between two cache servers. At the time of this speech being prepared, the draft about egress policy is ready to go publish as RFC 8893, and the one about the RP requirements have been published at RFC 8897. Coming to the end of my presentation, I would like to share some of my humble opinions about what's selected for the IETF side of the working group. One is, well, in the next, I think the side ops is going to solicit input from increasing number of operators to identify issues which interaction with the non-CIDR aware / CIDR aware internet, and to determine solutions or workarounds to those issues. The critical mass of RPK deployment is being reached. And second, SciDops is going to design RPK deployment models that fit into the evolution of network technologies and architecture. And the last, the SciDops is going to seek countermeasures to safeguard the RPK, which has become a global critical infrastructure of routing protocol. All in all, IETF SciDops will be very busy as the RPK is being widely adopted. Thank you. That's all about my topic.
Thank you so much, Dee, for your explanation. One thing I mean, again, as I said earlier, it's a new technology. People are deploying it, implementing it, and they are coming up with more feedback and what is broken, what is not right, and what should be fixed. And the discussion at times is a bit it's all over the place. It's very hard to build a consensus on few things. For example, the manifest, how to treat the manifest from the relying party software. So it's going to be a challenge moving forward, I would say. And thank you for your efforts in the CyberOps and all the other people who are putting a lot of effort in the CyberOps discussion. And if you are an operator and would like to understand how things work in the ITF, please join the CyberOps mailing list. You can just be a silent listener like me and understand how things are moving in the right direction, I would say. Thank you so much, Dr. D. Moving on to if there is any other question on this one. No, but you know how to reach to Dr. D. If you want to discuss anything, please, you can reach out to him directly, or you can drop an email on the Routing Security SIG mailing list so that we can have a discussion over there as well. Thank you. Moving on to the next presenter. And we have Melchior Elmans from Juniper Networks, and he will be talking about something slightly different, which doesn't talk about RPKI and ROA or ROV, but still under the umbrella of our routing security, something which we are not focusing these days. So over to you, Melchior.
Thanks, Aftab. I'm sure you can hear me and see my slides now.
Absolutely, both good at.
Perfect. So yeah, so changing the topic a little bit, although this relates to BGP security as well. And by the way, great work on all the CyberOps things going on and the deployment of RPKI in general. So, but there is more than looking at the updates BGP sends around. There's also something that is called transport security, and in particular securing long-lived TCP sessions like BGP. So probably you all have used or are using MD5 to do so. However, 10 years ago, a RFC was published out of IETF work that describes a new method, or back then it was new, which is called the TCP authentication option, and that was suggesting to replace MD5 for TCP transport. So we'll look at why finally there is some implementation work happening. We'll quickly touch on that, and we'll look at what the TCP authentication option actually is. Right, so what are we protecting? I already mentioned long-lived TCP sessions, and for example, those are BGP sessions, LDP sessions, but could also be other applications. And with other applications, I do come back to RPKI because tcpao could, for example, be used to protect RPKI RTR sessions, as that runs over TCP as well. So, and with that, we're trying to protect us from the blind insertion attacks and replay attacks. So let's quickly look at what a blind insertion attack on a BGP session looks like. Basically, in this example, we have two routers, router A and B, and they maintain a BGP session to exchange routing information. Now, our enemy router C is trying to send packets to router B as well, with a spoofed source address. The payload is TCP, and reset bit is set, and it uses the BGP port 117, TCP 179. And it tries to break into the conversation, if you want to say, by using random sequence numbers. That is not per se a problem, as BGP will discard most of the packets because the sequence numbers won't match. However, as it is a long-lived TCP session, there will be a point where router C guesses the sequence number correct, and obviously is then able to reset the BGP session as the TCP reset bit was set. So this is typically an example of what could happen on an internet exchange or a segment where there are multiple speakers. So our legacy solution, MD5, obviously prevented that. That is the reason why we've been, or one of the reasons why we've been using MD5 to protect BGP sessions, right? So basically, our router A and B are configured with MD5 using a pre-shared key. That pre-shared key is used to calculate the message authentication code, or to abbreviate it, the MAC, for each TCP segment. So MD5 calculates the MAC and includes that MD5 signature option in each segment and includes the MAC. The receiving node then calculates the MAC for the segment, the TCP segment it receives. And if the calculated MAC does not match the MAC it receives, then it will discard the packet. So far, so good. However, by now, or actually by 10 years ago, when the RFC was published, some new requirements came up. For example, MD5 does not offer the option for rekeying. In other words, if you want to start using a new key, you first have to tear down the TCP session, configure the new key, and bring the session up. In other words, BGP will flap. And MD5 doesn't support the use of multiple authentication algorithms. As I said, pre-shared key change not possible with the problem or issue that keys were actually never changed in practice, which is maybe not handy if someone leaves or starts working with your competitor and is peering on the same internet exchange. That could potentially be an issue. Authentication algorithms have changed over time, so there are stronger algorithms. One of the reasons why MD5 is deprecated, and even stronger authentication algorithms are expected in the future. For example, something which is now happening and we see more ask for is QKD, quantum key distribution. You could derive those keys from QKD and use those, for example. So there's new requirements there. tcpao to replace MD5. Why? Because it does support to change the keys without resetting the TCP session, and multiple authentication algorithms are available and supported. So quickly looking at how TCPAO works as a concept. Basically, we configure one or multiple master key tuples, MKTs. We configure them on each node, and we use these to derive the traffic keys. And the traffic key is then used to generate a MAC for each TCP segment, the message authentication code, and then that a MAC is then used to authenticate the TCP segment Now the MAC contains a key ID and the received next key ID. Basically, if you send a packet that is where the tcpao option is enabled, then the receiving node will look at what key is configured. And in other words, it sends back which, the sending node will send the R next key ID. So the receiving node knows which key to use for that packet. The master key tuple consists of the source address, destination address, source port, and destination port to identify the TCP connection. The TCP options flag determines which TCP option is covered by the MAC. And basically, there is a identifier, the sender used to generate the key ID on outbound segments, and the receiver uses the resolve key ID, as I just mentioned, on the inbound segment. And there is authentication algorithm, master key, and the key derivation algorithm. So if you look at then, if we pull it together, as I said, each node is configured with one or multiple MKTs. Each node derives traffic keys from that MKT, and each node independently determines which master key tuple is active. How you do that and how you negotiate that with the other side is not in scope of the original RFC. So that could be either by regular post, email, phone call, a pigeon, whatever transport you prefer. A lot of the implementations do offer the options to specify a start time and end time for each key. So in other words, we can agree that we'll change the key tomorrow night at 2 a.m. UTC +8, for example. So that is an option that allows the key rollover. And as I mentioned, if you're using QKD or some other external mechanism to create those keys, then obviously you can configure when those keys will change. So if we look at the step-by-step, the sending node procedure is you calculate the MAC for each TCP segment by using the appropriate authentication algorithm, calculate MAC over the TCP segment and activate the traffic key. Then in the header, you include the tcpao signature option, which includes the MAC key ID and the receive next key ID. The receiving node procedure calculates the MAC for each received TCP segment and uses an algorithm and traffic key associated with the received key. And obviously, if the calculated MAC does not match, it drops the packet again. So a lot of the arguments we've heard, so there has been a few people discussing this with operators, and one of the arguments we've heard is that why do we need this? Because we have GTSM. GTSM works very well, especially on, for example, again, peering operations. In very short, GTSM sets the TTL to 255, and if the receiver receives a packet with TTL that is less than 254, it will reject the packet. That obviously works brilliant. However, on an internet exchange or a segment where there's more speakers, then obviously you can still do the blind insertion attacks. And so we still would need MD5 and now tcpao in order to protect eBGP sessions from attackers that are one hop away. And obviously GTSM doesn't help in iBGP situations, so in your internal network. Beyond that, as I said, tcpao is more, it solves a broader use case than, or serves a broader use case than just BGP, right? Also LDP, and in the future, probably RPKI, RTR as well. So touching on implementation status and some further reading. The code is now done and available in production versions for Nokia and Cisco. Juniper is about to release in 20.3 R1 the code. The code has already been tested with Nokia, and we're in the process of testing it against the mentioned Cisco iOS XR versions as well. We are also, and with we, I mean Greg Hankins from Nokia, myself, and people from Cisco are working on a small virtual lab. Whereas if you're interested, you can contact one of us and ask for access so you can play around with it yourself. And we've started a page on GitHub, github.com/tcp-ao, where we're collecting information. So there's some examples on the IOP test we did between Juniper and Nokia, and you can find the configuration examples there. Obviously, if you are interested in implementing this, if you're interested in testing, please do reach out. As I said, either to Greg Hankins from Nokia or myself, if it's related to Juniper. And we're happy to help, happy to advise. Some of the other work in progress is we're trying to see if we can get Wireshark and TCP dump to support this as well. And obviously we're looking into upstreaming the code in order to make it available for example for the BSD and Linux community. And that's it. Thank you very much.
Hey, thank you so much, Melker, on that one. And just a quick one before there are two questions. So you mentioned the Cisco stable since iOS XR. After looking at your presentation, I actually looked up because I run iOS XC. So I have Gibraltar. It also has a support for it. I haven't tested it myself, but the iOS XC Gibraltar, which is 16 point after 10 plus something. The support is there. Of course, I haven't tested it. Probably I'll make sure that I test something and then update you on the GitHub page. Yeah, thank you so much for that. There's one question from Jeff. Let me read out for everybody is RFC 5925 points out that the connection that are known to use tcpao can be attacked by transmitting segments with invalid MACs. How can a tcpao speaker defend itself against such brute force DDoS attack?
Excellent question. Let me reread in the meantime. And by the way, thanks for your suggestion on the implementation status list. I'm happy to hear your results of the test. Yeah, I need to look into the question to answer that. I don't know the answer from top of my head currently. So Jeff, I will reach out to you offline for that. Thanks.
Okay, perfect. Another question is from Natalie, which you did explain. Do you know which vendors have implemented tcpao? So the list is in the presentation, and I think I'll test more and provide details.
Yeah, so currently it's Nokia, Cisco, and Juniper. So those three I know for sure. If there's others you are aware of, please do let me know. I would welcome more vendors on that list, obviously, because after 10 years, it's finally time to replace MD5, I think. So, so definitely, yes, if you know of others, please let me know.
Okay, Huawei, and again, it's just a question from Natalie, Huawei, other Arista. Yeah, if somebody is on the list listening from Huawei, and if they have any feedback, please share it with us. I haven't used Huawei for probably a decade now, so I have no idea. Arista, again, I can have a look, running some code in the lab, so probably I can provide more update. So perfect. One last question. right? So I still recall a very long discussion started by our very own Randy Bush on the same topic of MD5 and TCP reset on the BGP session, right? And there was a discussion saying it's not a big problem outside an IX. So do you, I mean, IX is, of course, the over-reliance of everybody on IX is, of course, a big problem. And it's a big enough reason to protect it. But do you think this is a problem outside an IX infrastructure?
Well, as I mentioned, it could also be used, of course, to protect iBGP sessions. The risk there could be smaller. However, if you're compromised some ransomware, you never know what someone brings into your network. So I would suggest to use something to protect BGP sessions internally as well. Right, you won't want to have your network going down or parts of your network because of a blind insertion attack, which comes from within your network. So yeah, I mean, another question I see a lot is why not use SSH or TLS, for example, as well, right? Because I don't know if the question was asked, but normally this one pops up as well. Yes, you could use SSH or TLS. However, it doesn't protect you from TCP header attacks, right? So it does protect the payload, but not the header itself. So so there's pros and cons, right? I mean, I see why people would want to use certificates these days instead of pre-shared keys, etc. But the idea behind AO was basically to replace MD5 with something that is as simple as MD5, right? You only have to agree on a pre-shared key and you're basically done. But so yeah, I mean, the biggest risk is obviously coming back to the question on an internet exchange. But I would suggest every operator to also protect its iBGP sessions or other internal TCP sessions.
Yeah, and in general, and if you are using an MD5 with any of your eBGP session, probably it's a good idea to move to the AO, right? Because a lot of big operators are actually still using MD5, and they provide you a password to just so that makes sense.
And they can live next to each other, right? I mean, yes. You cannot do AO and MD5 on the same session, but obviously per peer you could migrate to AO.
This is awesome. Sanjay, I was asking if there is anything on the MikroTik. Tongue in cheek, I would say, Dave, I don't know. There's so many things in the router OS available, probably yes. And someone is asking any idea about the bird of Quagga or the newer version of Quagga. I would say FRR, I would add to that one.
Yeah, so they are, they're basically waiting on someone to do the kernel code for Linux or BSD. So I know that Ron Bonica, one of our DEs, is working with a group of students who are interested in actually upstreaming that code. So that is to be expected, because obviously when the kernel code is done, it's easier for BGP and Quagga and FRR and others to build their code around that.
And another daemon which our very own friend Job likes is OpenBGPD. I would say it should be available soon.
Yeah, yeah. Well, Job is the same, right? I discussed with him, and basically he's waiting for someone to do the kernel code.
All right. Okay. Perfect. On that note, thank you so much, Melchior. If you have any other question, concern, you can of course reach out to Melchior directly, or you can just drop an email to the Routing Security SIG so that people can join the mailing list as well. Thank you, Melchior, for your time and your sharing the information with everyone. Thank you so much for your time.
Thanks.
Right, and then we have the last speaker of the SIG, and we have our very own George Michelson to share the implementation of AS0 TEL. So over to you, George.
Hello, Aftab. I'm just about to share my screen.
Take your time. Have
the slides come through?
Yes, it's good to go.
Great. Hello everyone, I won't take up too much of your time. I want to give you the implementation report for the AS0 activity. So as you know, AS0 for unallocated and unassigned resources, Prop 132 has been fully implemented, and APNIC is now publishing an AS0 ROA for all of the undelegated resources that we hold. To clarify, they are the resources which you can see in the public delegated stats file as either available or reserved. And if you don't know what AS0 ROA is about, its definition is that it's a disavowal of routing origination. There's actually an analogous concept in DNSSEC, which is authenticated denial of existence. So it's making a positive cryptographic assertion that something shouldn't be seen. And an AS0 ROA is a positive cryptographic assertion by the holder of the resources that they don't want them visible in a routing context. So this has now been fully deployed. It's a system that's under full monitoring. We're using cloud distribution, and we've put it under a discrete TAL. This is actually the second time round because we did implement a testbed for Apricot earlier in the year using the krill system. And we also used the delegated files, but that system was using soft keys and it was running on a VM inside APNIC's test network. There were about 10 users and we confirmed some problems in the deployment. We have now gone into production and we still use the delegated file, but we've deliberately included a publication delay so that we can cover for accidents in production of a delegated file, because we really badly don't want to mispublish any validly routed resources into AS0. The other thing we've done is we've done structural improvements in registry, and we can now apply any delegation change, which means an object should be removed from AS0. We can apply that within a 5-minute boundary in main RPKI, where positive assertions get made, or in AS0, where these authenticated negative assertions get made. And we are collecting stats on use, and we're going to continue presenting on that to the routing security SIG if that's what you'd like. So there are multiple components of this deployment. The in-house part is running on a VM. It's very tightly coupled to our registry, and we use an HSM as the trust anchor. And this is to give the same level of community assurance for what we are doing as our main RPKI. The cloud component, which runs in Google, is so that we can distribute rsync and RRDP. And we will be doing full distribution to second and more nodes as we have a platform that can encompass more locations. The architecture is quite complicated. We have two clear boundary of separations with an on-premises and an off-premises component. And we've made quite high use of Kubernetes as a model for deploying this service. It has some huge benefits in terms of service reliability. It will automatically restart services when it detects trigger events. It makes monitoring more easy, and the scalability for future deployment is very, very high in this model. But it did add some complexity to our solution. That's why we took so long to do it. So where to from here? Well, from here on in, discussion about this service happens here. I am the servant, you are the masters. Tell me what you'd like to hear about the behavior of the system. To bootstrap, since we are here, here's some initial information. Job Snijders, during our late stage deployment testing, told me that from the 65,000 approximately prefixes that are in AS0 for APNIC, somewhere around 69 routes in the global default free zone had been seen and marked bad. So that's the applicability of what we're publishing. We released service on the 1st of September, and since that time, we've seen 24 ASN fetching. And we'll give you more stats as we develop a better traffic profile. This is the set of AS that we've seen, and I pruned from this the home AS Superloop, which is myself. Now, Superloop did recently announce into Osnog that they were doing RPKI, but I think it's very likely that what I saw was my home office testing the service. So I did remove that, but all the other ASs here are the visible endpoints that we have seen connecting into this service. The rower is a single object. We decided that rather than creating a tree of a huge number of discrete objects, we would try to make a single signed object to reduce the burden in fetch and in processing. It's a MEG, so it may be one of the largest rower you're routinely going to see, although I suspect it isn't the largest. I think it's likely that some ISPs have sufficiently complex routing outcomes that they have longer assertions of prefix lists inside their AS and in their rower, but that's how big it is. And it's actually about 66,000 prefixes, 1.5 thousand of them v4 and 64,000 of them v6. The reason we have such a huge disparity between the two communities is because the IPv6 count is strongly affected by the implementation of sparse allocation. Sparse chops up the whole of our /12 into a huge footprint of resources that are as far apart as we can humanly make them. And the thing with AS0 is that all those gaps in between the parts we've given, every one of them has to be represented as a prefix in this rower. And because we no longer have strong alignment because of subsequent allocations, several of them aren't just one prefix, they're the small change problem. They're the big prefix, the next big prefix, the little prefix, and the teeny weeny prefix at the end. So we do have a lot of V6 in the rower. That is all I have to give you right now, but I'm here to talk about this if you'd like to explore. And as I said, this service is now fully deployed and I am in your hands. Thank you.
Thank you so much, George, for providing an update. Yeah, I've moved from the testing tail to the actual HSM tail now. It's working fine. I mean, there was absolutely no problem with that. So now there are some questions. So let me start. One is from Anurag. He's saying how it works in an NIR context.
So this is a very good question, Anurag. Thank you. NIRs have two kinds of resource that they receive from us. They have what are called the historical blocks, where we gave them large tranches of address, and they would then subdelegate from this. And they have the subsequent behavior that we call direct allocation. So when we gave an NIR a block, the whole of that block became in use. So nothing in that block is listed in delegated as reserved or available. So for the blocks, they will not appear in AS0 because at this time, the returns to those blocks remain inside the NIR and they remain in that country for redelegation directly under the NIR process respecting address policy. For the direct allocations, it's more complicated because the NIR has a functional choice. They could choose to retain use inside their structure. They could choose to use merger and acquisition or other transfer process, and those resources in principle could stay within their locus of control. But it's more normal that we would expect to see returns come back to a PNIC, and they will ultimately go into a terminated state and then be marked reserved while they go through cleaning, which has a lifetime, and then become available. Those resources should appear on AS0 because AS0 aligns with the state of the delegated file. So Natalie has asked, the 69, are they in IPv4 or IPv6? My belief is that almost all of these prefixes were in IPv4. They were the very small amount of visible state when Yob was testing that was exploiting the unallocated IPv4 spaces. They may well have been transitional because we all know that there are some practices on the fringes of BGP routing where people will pop up a prefix, do something they'd rather not have to own up to, and then pop it down again. So something we probably need to do is give you, the community, a report on the distribution of the effectiveness of this service against the visible routes, and so you can understand the applicability. So I'm going to take what you've given me as guidance for how we might inform you about our future activity.
So on the same note, if you are willing, if APNIC is willing to provide more statistics, then it would be using the YOP tool, which actually look up all the bad advertisement on the global routing table and provide the feedback that this is actually, this is what it is trying to solve if you add this tell. So right now it is you have to opt in to get this tell. This is not by default installed into the tell. You just have to install it. It's the process is pretty simple. So you can have a look and test it yourself if required. I just checked it. It's like 66,195 rows are there in under the AS0 tell right now.
Prefixes.
So, yes,
one rower, 66.
Sorry, prefixes. Yes.
Yes. And I do need to be quite clear that at this time, APNIC does not recommend routine inclusion of this data in the calculation of your forwarding intent. We think you should use this for monitoring. And we've made a couple of statements in the public web, which are linked from the TAL archive and from the blog article to explain our thinking at this time.
Yeah, which makes sense. Fine. So we have another question from Dima, who had a hand up. He is here, so he can probably ask this question directly. Go ahead.
Hi, George.
Hi, Dee.
Dee, long time no see.
Good to see you again. How can I help you?
So first of all, I would like to extend my thanks to your sharing of APNIC service about AS0 tell. I'm wondering, is there any possibility that APNIC is going to provide alternative approach?
Such as using the Slurm file?
Yes, exactly.
We don't have any declared intent to explore use of Slurm at this time. Slurm, this is a personal opinion, you understand, Dee, but Slurm is a mechanism which I feel is designed for an AS to use inside their routing behavior to mark networks as special so that they should be never repudiated. It's a mechanism for people who are necessarily using resources that they can't make RPKI for, have a higher trust boundary, and have a file that says, yeah, but I use these things. And obviously they shouldn't leak them, but the point is they won't reject them in their own IGP, rooted within their own framework. It's not a cryptographically strong assertion. So although we could publish a Slurm file, and we could even sign the Slurm file, there would be no cryptographic validation that respected the contents of the certificate and the contents of Slurm, because there's no statement cryptographically linking RPKI certificate contents with the contents of the Slurm file. And that is essentially the barrier to why we felt we didn't want to do this. It is not that Slurm mechanistically wouldn't work. The reasoning was it has no additional cryptographic value to a simple assertion by fiat, don't route these nets. And we just didn't see the additional value. But I can be convinced, and if there's community drive or if there's a push that this should become part of our service, we can take that under advisement.
I understand your concern, but how about APNIC member to get a Slurm file which contains AS0 information from its my APNIC account? So I think it will be a safe.
I think we probably should go into a conversation about service models where we could entertain doing that, and that would become an opportunity or feature we might discuss. So it's an interesting idea, but we aren't strongly motivated to add Slurm to our public assertion in this space at this time. But it's a conversation, and we're in the routing SIG. We can talk.
Yeah, so on the same topic as Dee raised, I can run a Reliant party software right now and add the extra A0 tell into it, right? And on the basis of that, I can dump a CSV and create a Slurm file out of it. Or even I can create a JSON and I can create a Slurm file out of it, right?
Yeah.
It doesn't create a trust because it is me. If it is coming from APNIC, it has some level of trust. I would say if I'm downloading it from my APNIC and I'm giving my credentials, probably there is a trust. This is, I think, where Dee was going.
We're using trust in a slightly different way to the nature of trust in RPKI, which is a formalism of cryptographic validation against extensions in certificates. And I'm really only a little legalistically pushing up to that barrier. Nothing you've said is wrong, Aftab. Nothing D said is wrong. I'm just pushing to that barrier. This is a cryptographically provable assertion of our right to make this statement. Slurm files, there would be a dissociation. The slurm would say what we thought. The signing of the slurm is not bound in a standards defined validation model at this time. It feels weaker.
Yeah, absolutely.
That's really it.
No, that I mean, that by definition, that is actually the case, right? It doesn't provide you the, there is no cryptographic assertion into it that whatever you're getting is valid.
I'm terribly sorry to do this to you, Aftab, but I actually have a second call on my time.
Okay,
I was asked
and
if
I don't know,
be...
we are already 6 o'clock. We have already way above our time.
Yes, Sanjaya has made the observation, which I would second. There's potential we could sign Slurm using our mechanism called RTA. And when we have done some further work in RTA, I think there'd be some interest in announcing things we can do with it. So I'm going to pick up on that idea of Sanjaya's and say, watch this space. But we are in mid-flight on RTA. That's not being announced in this interval. We have work afoot that will be exposed in the next APNIC Apricot meeting.
That is good to hear. Thank you so much on that note. Thank you so much, George, for your update. And we're glad that APNIC has implemented that policy, and now it is available for the members to and the operators to use in whatever ways they want to. But for the time being, just use it for testing and see how it goes. So thank you so much, everyone, for joining the session. On this note, I would say we will definitely be available through the mailing list, which is Routing Security SIG mailing list. Please subscribe to that. We will try to bring more discussion onto that one. Just for the time being, I would say you can rate the session. I'll hand it over to the MC.
Thank you, Aftab, for moderating the session, and also to our great panel of speakers. I am now inviting you to complete the poll survey, which should be in your screens right now. This is the end of the Routing Security SIG and also the last session for today. So we have more sessions coming up for tomorrow and hope to see you all. Bye, guys.
Bye-bye, everyone. Thank you.